Okay, welcome to online learning, and we are starting chapter 12. This is trigonometry. We're starting with section 12.1. We'll cover it today, and then tomorrow the next lesson will be on 12.1 again, word problems. So we are starting with a topic that you probably did last year in geometry, which is special trig functions with right triangles, and we're starting off with SOHCAHTOA. Right, so SOHCAHTOA is this acronym here that helps us to remember the relationships of the angles and sides when we're talking about right triangles. So you'll see here I have sine of theta equals 7/25. So theta is an angle measure. So it might be, sine of, and then how many degrees. So theta is an angle. So sine of 30 degrees, sine of 60 degrees, sine of 70 degrees, sine of 180 degrees, right? Any number there for an angle measure. The 7 and the 25 are the lengths of our sides. So what we're going to do is draw a triangle, always a right triangle. And I'm just going to put theta in one of the two other angles. Remember, these are acute angles all the time, right? A right triangle is a right angle with two acute angles. And so I just picked one of the random corners. So SOHCAHTOA, if you remember, right, it's sine. The S is for sine of theta. Don't forget that theta, all right? If you just write sine equals, you're really hurting the notation here. So sine of theta equals, the O and the H are opposite over hypotenuse. So when we're looking at theta here, the opposite side is this side right here. It's directly across from the theta. And so that side is going to be 7. Hypotenuse is always the side across from the right angle, which is this side. So that's always the hypotenuse. In this case, the adjacent side is what our A is going to be. The adjacent side is this side right here. Now the theta has two adjacent sides, adjacent being next to, right? This side right here is adjacent, and this is also technically adjacent, but hypotenuse is always hypotenuse, so therefore adjacent is reserved for one of our legs. Now notice that if I had put, if I had put theta in this corner over here, then this side would have been the opposite side, and this side would have been the adjacent side, right? So it changes based on where your theta is, right? So cosine, back to black. So cosine of theta, right? The acronym cosine is adjacent over hypotenuse, right? So in this problem, in this example, sine was 7/25. Adjacent would be, now we have to do, to find this adjacent side, you would do the Pythagorean theorem. Or if you know your Pythagorean triples, you know that this side is 24. A squared plus B squared equals C squared. So adjacent would be 24/25. Tangent of theta, right, TOA, TOA, is opposite over adjacent, which in this case is 7/24, right? With these fractions here, you should always simplify them. And if there's radicals, which there will be, make sure you rationalize them, right? So no radical is allowed in the denominator, okay? Watch your notation, right? When you're writing sine, cosine, and tangent, it's just those three letters. Don't make up your own abbreviations and write SINE, right? Use the abbreviation that's here. Make sure that you have that theta. That's super important. And all lowercase for our letters. This theta could be any symbol, right? Theta is just the most common symbol. It could be tangent of x, right, where x is a degree of angle measure. It could be tangent of a, right? You can use any variable or symbol you want there, but theta and x and a are the most common. All right, so here's our theta right here. What the directions say to do, find the value of sine, cosine, and tangent functions for theta. So you can pause the video, give this a try, and then come back, unpause, and check your answers. So for this one, you would say that this is the opposite side. This is the adjacent side. Here's your hypotenuse. Pythagorean theorem tells you that your hypotenuse is the square root of 17. So sine of theta is 1 over root 17. Rationalize that, you get root 17 over 17. Oops. Cosine of theta would be 4 over root 17. Rationalize that. And tangent of theta is just 1/4. Okay? Now, we talk about the reciprocal functions. So a reciprocal means we're gonna flip it. So if we take sine, the reciprocal of sine would be 1 over sine of theta. So take this guy, right, and he's the easiest one to take, and just do the reciprocal, right, flip it. So that would be root 17. Now, we don't write this as our answer when we talk about reciprocals. We give this part right here a special name, a new name. So the new name for this guy, 1 over sine of theta, is cosecant of theta. So cosecant is the reciprocal of sine. You would write your answer this way. All right. So the reciprocal of cosine, when you do 1 over cosine, we call that secant. Right? So secant of theta, again, I'm going to take this and flip it. I'm taking this one and flipping it because then I don't have to rationalize the denominator. If I take this one and flip it, then I'm going to have a radical in the denominator and I'll have to rationalize. So 17, root 17 over 4. And then if I take the reciprocal of tangent, we call that cotangent, and that would be 4. So altogether, we will usually ask you for the 6 trig functions. So that's sine, cosine, and tangent, and their reciprocals, cosecant, secant, and cotangent. Okay? So now try this example. Pause your video. Try this example. Try to make sure you're focusing on your notation. Simplify all your fractions, and then unpause and check your answers. All right, so here are our answers. Check to make sure you simplified completely. Check your notation. Make sure you have thetas in every answer. All lowercase letters. Make sure it's the correct letters. So cosecant is CSC, right? Don't make up your own abbreviation, okay? All right, and this hypotenuse was 82, right? This was the opposite side. This is our adjacent side, and this is our hypotenuse. Okay, next. So next we have trig ratios of special right triangles. You should have learned this again in geometry. If not, you're about to learn it now. So there's a ratio of the sides here, about the lengths of the sides. You may have learned it this way. So across from the 30 is x, across from the 60 is x root 3, and the hypotenuse is 2x. Okay, so when we're asked to find the sine of 30 degrees, right, opposite over hypotenuse, there's my opposite side, x. Here's my hypotenuse, 2x. If I simplify this fraction, it's 1 over 2. So sine of 30 is 1 over 2. And with these special right triangles, you can do the same thing, do SOHCAHTOA for every angle measure and find all the trig functions. And these trig functions are used a lot and often. So we could repeat the same thing for cosine of 30, right? And do x root 3 over 2x, and that would simplify. And when that simplifies, you get root 3 over 2. So cosine of 30 is always root 3 over 2, no matter what. Just like the square root of 16 is always 4, right? Cosine of 30 degrees is always root 3 over 2. Tangent of 30 degrees is root 3 over 3, and that's after rationalizing it. And then we can do the same thing for 60. So sine of 60 degrees, cosine of 60 degrees, tangent of 60 degrees. Okay? With the 45, 45, 90 triangle, your ratios are x, x, x root 2. We could do the same thing with SOHCAHTOA. So sine of 45 degrees after rationalizing. Cosine of 40 degrees is the same. That's 1. So these 9 values and their reciprocals are used a lot for the rest of the chapter. So by the end of the chapter, you should know these off the top of your head, what these values are. This box right here, these and their reciprocals, you either need to have them memorized or be able to recreate them by drawing these triangles and doing SOHCAHTOA. These questions would be on a non-calculator section of a quiz or a test, and you would be have to generate these answers on your own. Yeah, I had another thought, but I forgot it. Okay. Oh, the reciprocals. That's what my other thought was. The reciprocals. So if you're asking for, if you're asking for cosecant of 30 degrees, right, you can do this one of two ways. If you already know that sine of 30 is 1/2, you can just do the reciprocal of 1/2, which is 2. You also, when you're doing cosecant, right, you can say, okay, if sine is opposite over hypotenuse, right, that's my SOHCAHTOA, then cosecant would be hypotenuse over opposite, right? So you also could do it that way. I just think about the sine of 30 and then flip that fraction. In your book somewhere, it's not this exact chart because this is from an old textbook, but there is a chart that looks like this in section 12.1. It has these 9 values that I was talking about that you have to have memorized. Okay. In the diagram here, they don't have the x's. They just put 1s in place of the x's. So what we're going to use those values for is to do problems like this. So it says use a trig function to find the exact value of x and no calculators are allowed, right? So you're going to look at the diagram. Let's do one together. You're going to look at the diagram and you say, okay, here's my 60. I have these two sides of the triangle. This is my opposite side, and this is my hypotenuse side. So which trig function would I be using to solve for x, right? You either have to pick sine, cosine, or tangent. So because I have opposite and hypotenuse, I'm going to use sine. So I will say sine of 60 degrees equals opposite, which is x, over hypotenuse, which is that, right? Now, sine of 60 degrees is not going to stay as sine of 60 degrees right here, right? You're going to change that, and we're going to change it to its value. And this is where you need to know the values from this slide right here. So sine of 60 degrees, either by memorizing it or recreating the triangles, you would know is √3/2. So you can change it now, or you could change it once you isolate x. It doesn't make a difference. So I'm actually going to, for this problem, I'm going to isolate x first and say 100 sine of 60, right? Just multiply both sides by 100. And then I'm going to replace sine of 60 with √3/2 and simplify that. And this is your answer. Now, we are saying no calculators. So this is your exact answer, right? It's not a rounded answer. It's the exact answer. That's why no calculators allowed. The book will give the answer in the book as a decimal. We're not going to do that. So we're going to ignore that and always give the exact answer. So go ahead, pause your video, try example 4, and then unpause to check. So on number 4, again, this would be the hypotenuse side. This side is my adjacent side. So this time with adjacent and hypotenuse, I'm going to do cosine. Right? I could change cosine of 45 degrees right now to √2/2, or I could isolate first. So this time I'll change it right away so you can see what that would look like. So I changed cosine of 45 to √2/2. And then you can either multiply both sides by 20 to isolate x, or cross multiply, right? Your choice. And so you should get 10√2. That's your exact answer. Okay? Now, what happens if this angle measure is not from a special right triangle? Right? What if the angle measure is 35 degrees, right? So then we do need a calculator. So notice the directions say find the approximate value of x, round to the nearest hundredth. So I'm going to do the same exact procedure. Go ahead and you can pause and try to do as much as you can. Right, so I don't know the value of tangent of 35. I'm not gonna grab my calculator yet, right? Because I don't want to write a rounded decimal there and then multiply, right? We want to save all the rounding for the very end of the problem as always. So let me show you a little bit more work. So I'm going to multiply both sides by x. And then you can divide both sides by tangent of 35 degrees. So x equals 29 over tangent of 35 degrees. So then you would grab your calculator and put in 29 divided by tangent of 35 degrees. And you should be getting this decimal. Now, some comments about the calculator. If you're using the school calculator, the TI-34, your sine, cosine, and tangent buttons are under Trig, I think. I know I can't find them off the top of my head. Yeah, Trig. So where the pi button is, you would press second pi, that says Trig, and then you've got your Trig functions listed there. So we're only using the first three for now. The inverse of sine, cosine, inverse of cosine, tangent of inverse tangent, ignore those. It's just the sine, cosine, tangent. So you would just press 29 and then divide it by tangent and then put 35 in after you get the tangent on the screen. Make sure you're in the right mode. So if you check your mode, the very first line, it says degrees and then RAD, that's radians. You want to make sure you're in degrees. If you have another calculator, you would also want to check your mode if you're not getting the right answer. You're probably in the wrong mode or maybe pressing the wrong button. If you have issues with the calculator, that's something we can do the Google Meet to discuss, and you can show me your calculator and I'll help you with the buttons. All right, so that's today's lesson. Your homework assignment is listed here. It'll also be posted on Classroom. Notice for numbers 5 and 21, you're not using a calculator. That's going to be like these problems right here, right? So no calculators, give the exact answers. Ignore the answers in the book. I posted the answers for those separately. Check your own odd answers in the back of the book. I gave you the page number there. And our joke of the day, got to keep that going and laugh a little bit today. Why did the 30, 60, 90 triangle marry the 45, 45, 90 triangle? It's a good one. They were right for each other. Yeah, you're all laughing with me. I know it. All right. So if you have any questions, add it to our Chapter 12 question page. Be specific. Feel free to go back, watch as many times as you need to, and pause where necessary. All right. Have a great day, guys.